With that being said, I'd like to introduce our speaker, David Andrzejewski. David is a data sciences engineer at Sumologic, joining us in 2011 after a postdoctoral research position working on knowledge discovery at Lawrence Livermore National Laboratory. David's expertise is in developing tools that combine the power of machine learning with human insights, and he's published work applying these ideas to problems in biomedical text mining, information retrieval, and software behavior. David holds a PhD in computer science from the University of Wisconsin-Madison, and he is responsible for key contributions to Sumologic's machine learning and advanced analytics capabilities. David, thank you for presenting, and I'll hand it off to you from here.
Thank you very much for the introduction, and thank you to everybody tuning in for joining us today. So I'm going to start by giving a very brief overview of Sumologic and what it is and who we are and what we're doing here before diving deeper into the specifics of the detecting of patterns in the machine data. So Sumologic is a cloud-based log management, storage, and analytics solution. And what the logs are this machine-generated data, kind of the raw material. And basically anything that is a computer or a piece of computer software is going to be generating these logs. And given that computer infrastructure is the nervous system of modern organizations and businesses, there's a whole ton of this logs being generated from a wide variety of software components. So given that companies have all of their activity being handled by computers and that computers are generating these log messages, they can be tremendously important and useful for understanding computer infrastructure behavior and what businesses are actually doing. So one tricky thing with logs is there's a wide variety of them. So in this diagram, you can kind of see essentially a software infrastructure stack with different pieces of the infrastructure having different kinds of software components and different kinds of log messages. And what's really important to understand is that for these logs being generated for given events, like a customer logging into your website and trying to purchase something, that event is going to trickle throughout, it's going to resonate throughout the software stack across many different components. So these logs give you the picture of what's happening with your business, but to get the whole picture, you have to be looking at all the logs from the different components. So this kind of motivates the Sumologic approach, where basically all of the logs across the different layers of the stack that we had shown can be fed into our cloud-based solution so that they're in one place and we can easily slice, dice, and understand them and get some interesting insights out of them. So that the Sumologic cloud service gets the logs from all the different components of your software and hardware, puts them in one place, then we can start digging into them to really find out interesting things about how your application is performing, how your business is performing, security issues, all sorts of things. Like I said, if almost everything in your business is going through these computers and computers are logging, all the different software components are logging all of this, then by really understanding the logs, you can really understand all the different aspects of your business. So this can kind of be a big challenge. A moderate-sized enterprise can easily generate terabytes of logs a day, and it's difficult to have the infrastructure in place to handle just the volume of the data and the different kinds of logs that are being emitted by different components. So that's kind of where a solution like Sumologic steps in, where we handle some of the difficult parts of that so you don't have to. But once you've done that, once the logs are in the Sumologic system, the sky is sort of the limit on how you can slice and dice this information to find out what's going on. So the particular thing I'm going to be talking about is one of the neat features that I've been lucky enough to work on here, where we can detect patterns in the log data automatically. So this is part of the promise of a cloud-based solution, is that we can learn from the data and do some pretty neat stuff there. So I'm going to be kind of trying to motivate why you would care about pattern detection in your machine data by stepping through some problems and how our features are built around the pattern detection can help you out with those. So the very first problem is too many logs. So in the diagram before with the big infrastructure stack, that's a lot of data just in terms of volume and in terms of different kinds of logs. So if you're collecting from the operating system and your database layer and your custom application code, this is just a lot of logs to take in. And you need some kind of tooling, some kind of help to really be able to break it down to something that's human comprehensible. So this is a very basic search. So this is the search window. Some of our other marketing material and webinars have kind of gone through the very basics and some of the more advanced usages of the sumologic service. But for our purposes, this is kind of the window into the machine right here. This is a search bar where I've said source category. I have this source category kata, and this is some component of our system. And the search is going to return the logs that match my query. Now, before I go any further with this, I should mention that here at Sumologic, we're big believers in dog fooding. So that is, we have the Sumologic service, the cloud-based service that our customers feed their data into. And we also run a second shadow copy of Sumologic that we just feed our logs into so that we can use our own product to understand the behavior of our own product. And so actually quite a few of the features that people really like and that people find really useful originally got into the product because we ourselves wanted them there, because we found that need when we were trying to use the Sumologic shadow system to investigate or understand the Sumologic production system that customers actually use. So this is Sumo on Sumo right here. And this is, okay, give me all the logs for this one particular system component, source category. And this is all well and good, and I get this kind of scrollable, nice paginated list. I can go through, look at the individual logs. However, there are 17 pages, right? Or 716 pages, rather. And this is just too much for any human to really wrap their head around. I'm not going to read through more than 10,000 different logs. So the LogReduce technology is what you can get to by pressing this LogReduce button. And so after you've run some search, and you can say, well, more than 10,000 logs is just too much for me to really read one at a time. So you hit LogReduce, and it launches something that we call Summarize Query. So LogReduce is the underlying technology, and Summarize is the actual sort of feature that leverages it. I'm going to be using them kind of interchangeably today, but that's just so it's clear with those two terms. So let's say I press LogReduce and launch this Summarize Query. What I'm going to get is essentially the compressed, distilled version of the more than 10,000 messages I had originally had. So you can think of it as I've actually sort of compressed the data more than 500 times. I've gotten 2 orders of magnitude here. And what do I have, right? What's in this table now? So this is what we're looking at are the actual types of logs themselves instead of the individual log messages. So you can think of it as we're working on a fundamentally different level of abstraction. Instead of looking at raw messages, we're going to kind of take a step up in abstraction and look at message types. So, log data is kind of repetitive, and you can often categorize log messages into these different log types. And it's a lot easier to work with. So even though there were more than 10,000 messages before, now there's only about 20 log types. And so what I see is the signature, which is that type that's automatically learned by the system. And then I see the count, which is the actual how many logs match that. So what's really neat here is that while 10,000 logs is kind of an unstoppable deluge of data, 20 signatures along with their counts is more like a story that a human can actually wrap their head around what's going on. So we can in particular, we can look at these 2 signatures and we can say, okay, so we see these messages that are from, again, like I said, we're dog fooding the Sumologic system. So these are from Sumologic, and we're studying them in Sumologic. And this log right here is something that happens whenever anybody starts a search on the system. So, and then this one above it is whenever a search ends, this is the status. And we have, again, because I took this time, the numbers don't exactly line up because some searches started before the search and before the window and they ended within the window. But this really tells a story about what's going on in the system when some user runs a search. So while 10,000 messages is just more than any human can wrap their head around, 20 signatures in the associated count is something that's on a human scale. It's something you can tell a story about and you can understand what's going on in the system. So that's pretty neat. What you can do now is we can actually also say, okay, the types are very interesting, but if I want to see what were the raw logs that actually correspond to each log type. So you can do this drill down by simply clicking on the highlighted number. That's the count. So what we have up here is we have the original signature that we saw at the top level. And then below it are a bunch of logs that actually matched the particular signature. And the signature had these stars in it, which are kind of meant to indicate wildcards. And so you can see in the actual logs, there's sort of this fixed part of the log calling get details batch, module equals kata, all this kind of stuff. And then there are the fields that change, which server handler, what session ID, what actual specific host, all this sort of stuff. So when you observe the signature, you'll see this fixed part of the message and you'll see the stars. And that tells you how is this collection of logs the same and how is it different. And when we drill down into the actual logs, we can see the particular fields that are the same and are different across each log. And this is a really cool and interesting result, and this kind of tells us how many times we saw this particular get details batch, function or whatever it is be called by different parts of the system. One thing that's interesting, and we'll circle back to it, is that actually these logs, there's sort of two types represented here, these finish and start. So while they are both the same in the sense that they're very similar throughout, they're slightly different, and maybe we don't want that, and we can come back to that later, what you can do if the results don't exactly align with your understanding of the data. So how are we able to do that? What is going on under the hood? How did we detect those patterns, the similarities across the different logs, and group the logs based on their underlying similarities? So from a very basic level, most logging statements in software are generated by something called a printf function, which is basically almost every single programming language and logging framework has some variant of this printf. F stands for formatted. And what a printf statement has is it has some fixed string and it has some sort of wildcard parts in it. And it's meant to be kind of a template for how a log message gets emitted by software. So we have this print statement that might be in your code above, and then we have some actual logs that might be emitted by some code below. So the printf statement says health status check, host ID is host status, where host ID and host status are the variables that might change from log to log. And as we'd expect, the actual logs we view, health status check, Zim5 is okay, Ger3 is okay, Ger2 is timed out, okay, and so on and so forth. So the repetition that you observe in the actual logs is kind of a consequence of the fact that logs, different specific log messages, might be of the same log type because they're emitted by the same printf statement somewhere in the code. So what LogReduce technology tries to do is, from only observing the actual logs, sumologic tries to learn and infer the actual underlying printf that generated those logs. That's somewhere in your source code or the source code of your database or the source code of your infrastructure layer. So we try to kind of reverse the process and work backwards. And this is some of the sort of where the magic happens, and this is kind of the trickier part of getting it to work. But this is how we go turn it around and we say, what was the printf that actually generated this, given only the logs? And in the rest of this discussion and in the product, we call our recovered guess at the printf statement a signature. This is a log signature. So the printf is above, and the signature is health status check, wildcard is wildcard. So that's what's learned automatically from the sumologic system. And what this can be used to do, which is what we saw in the actual summarized query search result a few slides ago, is we can use these underlying signatures to group the logs by the signature. So this is the kind of result you'll see. Okay, health status check, wildcard is wildcard, 4. We saw 4 of those. And that's a much kind of more distilled, compressed way to understand our data. And you can sort of think of it as the sumologic is learning how to impose an order or a schema or some kind of underlying structure on the data, even though the sumologic service was not given that structure explicitly. It inferred what the signature was, and then it used those inferred signatures to group the logs. So we've kind of got a nice orderly, compressed way to understand our data, where before we just had a gigantic, intimidating mess of more than 10,000 separate log messages. So I hope this is kind of often enough to get people very excited by the prospect of being able to understand their data through this alternate lens, through this sort of auto-extracted schema of sorts. So let's step through another kind of a specific use case for this technology. So problem number 2, what errors are we seeing in our system? So this is a very common use case for Summarize and LogReduce. And you can just run this very simple query where now we're going to say, okay, source category stream, this is another Sumo component, and we add the keyword error, and then we pipe that to Summarize. And what's really interesting here is you can often do this to just understand, bring something to your attention that you wouldn't have necessarily known about. So there are 15,000 log messages being generated by this particular system component that have the word error in them. Of them, 11,000 are this exact same message about some disk file being deleted when it's already been deleted. So this actually has probably surfaced a bug in the code. And this really, if you saw the list of 15,000 logs, you might say, okay, I see a bunch of this, I see a bunch of that. But when you see the count next to the signature, it really makes it pop. It really makes it obvious that there's almost certainly some kind of underlying fault in the code or something that needs to be addressed. Why did we generate this exact same message 11,000 times? So somewhere in the code we're trying to double delete a file or something, and this really brings it into sharp relief and helps us understand what kind of error logs are being emitted by the system. So this is really a powerful lens for understanding behavior. So kind of a variant on that is actually troubleshooting and root cause analysis. So often if you're operating some kind of production service or internal infrastructure, you'll find out one way or another, hopefully from some of your own alerting tools, maybe sumologic, or in the worst case, you'll find out from your users or your internal or external that something has gone wrong, that parts of your system are not functioning as they should. So, for example, let's say that I'm running a sumologic service, which actually for purposes of this demonstration, I sabotaged myself and knocked part of the service down on purpose. And the user sees this error when they try to run a search and says there's a timeout processing your request. So in this hypothetical scenario, let's say that the user then calls whoever, or maybe it's somebody internal or external, and they get in touch and you're having this problem. Okay, what are we going to do? So as I'm troubleshooting it, I'm a developer or I'm an ops guy, hopefully I have at least some idea which component would be responsible for this kind of user-facing error. So let's say I run Summarize, I run LogReduce on the component that I sort of suspect to be the culprit. And I see this signature featured prominently where, oh, okay, session killer. So session killer, this signature pops right up to the top, and as somebody familiar with the code and infrastructure, I can say, oh, session killer handles some kind of timed out internal requests, and therefore the user-facing error is probably caused by this particular internal communications issue. So again, where perhaps there's going to be tens of thousands or hundreds of thousands of logs, if I can just see this signature along with some elevated count, that should be enough. That could be enough for me as the developer or the operations person to sort of have found the smoking gun that explains the behavior that the user actually had to suffer. So yeah, the kind of workflow you can use Summarize for in this case would be that some observed issue or metric or something tells you roughly where to look. And then again, Summarize gives you the log types being generated. So more than the specific messages themselves, just this kind of global bird's eye high-level aggregate of what log types are being emitted and how many of them. And that can be enough to sort of give us the hint or the clue to find what is actually going wrong with the system. So that can be really useful. So these are kind of two uses of the technology, and like I said, the fundamental idea is that sumologic will sort of learn these signatures from the log data, and then you can use those as a lens or a window onto your data. The next things we're going to talk about are how we can further kind of customize and extend and interact with this feature to get even better results. So the idea here is that the sumologic service should improve as you use it. As you use the service, it should sort of tailor itself and personalize to how you're using it and what you find most useful and relevant. So there might be certain signatures, like the session killer one that I just showed you, or something, or some kind of very critical error message that you never want to miss in the results. So in this example, let's say that perhaps I'm personally responsible for the database operations, and this log signature about databases shutting down is something that whenever I run Summarize, I really want that to be prominently featured. So I can hit that thumbs up button and sort of favorite or bookmark the signature, and it will be bumped up to the top of the results whenever it is present in the data and I run a Summarize query. And so this relevance score is kind of the way that we track the user feedback, and giving an explicit thumbs up to a particular signature pegs the relevance score at a 10. So it's 10 out of 10. It's always going to show up at the top, and therefore you're never going to miss it if it's present in the data. And what is also going on here that's noteworthy is that these other signatures, which you did not explicitly and say that you really thought were relevant or important, also kind of got a bump because they're similar. They seem to be related. Again, something that sumologic is learning directly from the data itself. They seem to be related to the signature that you expressed a strong interest in. So once you've given us some information about what is really important or critical in your logs, the service is going to learn how to combine that with other pieces of information to try to present you the most important insights into your data at the top of the results list. So, and again, this is all being done on top of that initial reverse engineering of the printf. So first, sumologic learns the printfs and the signatures from the data, and then as you interact with them, we try to learn which signatures and which patterns are more important to give you even better results. So sort of the flip side, the opposite of that problem, is there might be signatures that you don't care about at all. So for example, there might be various log messages that are emitted periodically all the time, and it's not something you are particularly interested in. So extending our example where I'm some database guy, and maybe I'm not really interested in compute jobs. So there's these logs about when compute jobs within our service are started or stopped or anything like that. I can take that log and give kind of obviously the opposite feedback, thumbs down. So when you give an explicit thumbs down, just as before, it's pegged at 0 and sunk to the bottom of the list. And again, so this is very important that we're not going to hide it or discard this data, but we're just going to kind of suppress it a little bit so it's sort of out of your way. And similar to the other example, we're going to try to take the user feedback we just got from you, and we're going to try to extrapolate and say, okay, well, our related signatures, maybe they're also going to have their relevance score lowered because it's so similar to the signature that you said you're not interested in at all. And again, so that's that other guy who you didn't explicitly give a thumbs down to, but it's had its relevance score dropped as well. And what's really kind of neat about this feature is that this is a much more powerful tool than simply editing your query. So before you said, oh, well, you're a database guy, maybe you should just add database to the search string so you only get database logs. But what you really are saying is you're really interested in the database signatures, of course, but maybe you don't want to completely filter out the other logs. So if we think way back to that sort of infrastructure stack diagram at the very beginning of the talk, we had events and system issues and stuff like that really traverses the stack. It spans different layers of the infrastructure. So maybe, of course, you're interested in database, but you'd also still like to see signatures related to operating system issues or your software stack or something like that. So hard Boolean filtering in the query search language is not really as powerful or robust a tool as this kind of relevance-based scoring. And again, if you could add not clauses to the search to really block out all of the compute logs, but again, then they're totally suppressed and they're completely gone from the result, and perhaps you accidentally overblock and you miss things that you really did want in there. So this kind of soft relevance scoring where sumologic learns how to assign scores to the signatures that it previously learned is really, it's just a much more flexible mechanism that can be really helpful for these kind of applications. So these signatures themselves, now we're going to circle back to what ultimately the results of Summarize and LogReduce are fundamentally driven by the quality of the signatures that sumologic is able to learn from your log data. So one failure mode of sorts is that perhaps distinct log messages are actually shoehorned into the same signature by sumologic because they have so much in common that the system sort of makes the mistake of thinking they're actually exactly the same. So this initial result that I had shown you earlier has this calling get details batch, session ID, all of this sort of stuff. It's a really these two log messages are very similar, but you can see when we dig down and do this drill down into the actual results that really it's kind of two different things. There's the start call and the finished call. And again, they're very, very similar, but really they're a little different. They convey slightly different information, and certainly they mean very different things to the end user, which is to say the end user of sumologic, whoever's looking at whether or not something started or finished. So this button right here, showing this sort of split behavior, you can actually say, if you do the drill down and you see this issue where two different logs have been forced into the same signature, you can hit this button and break them apart. You can kind of give sumologic the hint that really there's more than one thing going on here. It's being conflated. So by pressing that button, you're going to get this. This is the output of the actual system in the little example that I'm playing with here, where, as you would hope, it actually recovers the correct two underlying signatures that were really being falsely merged into the same signature. And when you give sumologic this kind of hinting or feedback to help refine the signatures, this is something the service will remember, and all future users of the service of sumologic within your organization are going to benefit from the 5 seconds you just took to hit that button and tell the service, okay, the signature is helpful, but could be a little better. So now anybody else in your organization that does a summarized LogReduce search is going to get this correct result below of the finished and started log messages being separate. So that the system, as you use it to study your log messages and kind of nudge it when things are slightly off, you're going to be rewarded with a better experience as the results grow more accurate over time. So as before with the thumbs up, thumbs down, there's kind of a flip side to this where you might say, did different signatures actually get forced into did we have basically this signature really is too specific? So we might have this guy right here, it's got just far too much detail and information, and really parts of it should be wild carded out. And what we can do here is you can hit this pen button that's highlighted, edit, and you can actually reach into the log message and say specifically which parts should actually be replaced with wildcards. And once you do that, you're going to be able to say that it's going to rerun the results and take other signatures that look like they fit under this guy and merge them all together. And so again, it's just basically the opposite problem of split. Now we can merge and edit signatures to really get the proper results where the wildcards are where they're supposed to be. So once you do these kind of things, hopefully the error troubleshooting and the root cause analysis that we discussed earlier is going to be more useful because the signatures themselves better reflect the underlying structure of your logs. So another very common problem is that you'd like to know how different machines from the same cluster are different or the same in their current behavior. So let's say that you have some cluster where you have all these different hosts that are all running the identical software and they're all playing essentially the identical role in your infrastructure. then you would hope that they'd be generating log messages that are roughly similar to each other. And what we can do is you can use summarize you can use the LogReduce technology to understand that. So this is kind of a sneak peek here thing, but this is something we've been playing with internally and we found quite useful, is with just a little tweak, we can get the summarized results into a form suitable for the Sumo language charting and visualization capability. So if you run out and try to do this right now today, you won't be able to, but in a week or two, this should be live for customers. And what are we seeing right here? So each different bar corresponds to some different host in our system that is from the same cluster. They're all running the same software. They're all playing the same role in sumologic. And the different colors and parts of the stacked bar chart represent different signatures. So what is really a kind of quite a sort of difficult and impressive thing to say is, across this entire cluster, I just want to have an at-a-glance visualization of what is behaving the same or behaving differently. By under the hood, taking the logs from each host, running them through summarize, boiling them down to the signatures, looking at the counts, and then visualizing them in this way, we can see that this guy, this host 13, is really kind of the odd man out. This is it's a big chunk of logs that are of a distinct type from anybody else in the cluster. So by combining the pattern detection of summarize and automatically inferring the signatures from the data, we can use that as a lens or a tool to understand behavior across this cluster of machines in a very fast, at-a-glance, convenient way. So some best practices for how can you, if you want to run out and start using this on your own data, which I would most certainly encourage you to do, what are the ways that you can really get good results and useful, meaningful insights out of LogReduce and summarize? And what I would say is this printf is not a great candidate for summarize. So basically, it's almost all wildcards. So in the percentage sign followed by a letter in the printf kind of syntax means that's a wildcard where some data is going to be substituted. And what this means is that each of these logs is going to almost be completely different from each other. So there's not much of a fixed structure to go by. If the service is able to learn a signature, it's actually going to be just a blur of stars and wildcards, which is just really not very helpful. So logs that look like this are just not a great candidate for this sort of signature wildcard aggregation. It's just not going to be very helpful. Another thing I would say is that if you have a large and complex stack of software and components, I would resist the temptation to try to summarize absolutely everything. So before we were able to get this 500x compression, which is great, but the thing is, if you have millions and millions of logs, probably thousands and thousands of distinct printfs, even boiling stuff down 500 times is still going to leave it at a scale that's not really that human consumable yet. So in the examples we kind of walked through where we said, oh, let's do error analysis or let's do root cause analysis, what's really helpful is to sort of do at least some filtering to break it down to say, okay, let's focus on a specific component or one or two specific components, and let's look at their logs and run summarize on that, because then you've narrowed things down a little bit and you're going to get results at kind of that human scale where you can have a better understanding of what's going on. So if you have an enormous software stack with 5,000 different underlying signatures, 5,000 is still probably going to be a little too much for you really to get a quick understanding of what's going on. So that's how you can detect patterns in your machine data with Sumo Logic. And this feature, really, the way to think of it is that it's going to distill many thousands of raw logs down to just this handful of signatures that you can just get an at-a-glance understanding of. And this is without you doing any work whatsoever except hitting that LogReduce button after your search. Sumo Logic will automatically try to reverse engineer the printfs and get you those signatures, which you can kind of understand, and then categorize the logs and count them by which printf they kind of go to. And there's a lot of applications for this. Fundamentally, it's just a different way of viewing your possibly very loosely structured log data. And it can help you finding unexpected errors or messages or signatures that really jump out at you. It can help you understand normal or abnormal behavior. And as you use the feature, there's going to be opportunities for you to sort of tell Sumologic service, which signatures that you are really interested in, and then make sure that those kind of show up at the top of your search results. And you can kind of nudge the results if they're not quite to your liking, and the service Sumologic will remember those results. And hopefully then on future invocations of the functionality, you're going to benefit from the kind of hints that you gave the service earlier. So we find this to be a really pretty useful tool internally for understanding our own system, and from discussions with customers, a lot of people have found this pretty useful as well, and they've come up with some pretty interesting applications like this kind of root cause analysis and stuff like that. So we think it's pretty exciting, and we're definitely continuing to work on it and tweak it and improve it and see how else we can exploit it to better get insights from the data. But thanks for listening, and I think we're going to kick off a further discussion of what we've just seen here.
All right, thank you, David, for an excellent presentation. As David mentioned, we will be kicking off our Q&A session right now. Please do enter your questions in the Q&A panel of the WebEx window, and I'll read them out loud to David for him to answer it. And so there are some questions coming in, so we'll go ahead and get started. The first one to David is around the topic of hints to summarize feature, and the question is, are the hints always public, or can the user keep their hints private, i.e. they might not be general enough to split apart signatures for all users?
Okay. So right now, the granularity of the hinting is within the entire organization. That's for the correctness of the signatures. So the kind of decision, this is definitely a tricky issue that we're always kind of looking into, and it's probably going to evolve over time. But the thinking was that fundamentally, if those, for example, the started and finished logs, they should be separate. If they should be separate, they should be separate for everybody, and we'd like everybody within the organization to benefit from what you've done. I can understand there might be cases where maybe for a different user or a different context, maybe you'd want to leave them together and just sort of blob them together like that. But that's something that we don't do right now. I would want to emphasize, perhaps I didn't and I should have, is that the relevance feedback is always personalized per user. So if you thumbs up something because you're the database administrator, the ops guy doing production incident troubleshooting is not going to see the relevance feedback, the thumbs up, thumbs down. They're not going to have those spill over into them. But the underlying correctness of the inferred printf signatures is something that's always going to be shared across the entire customer organization. So that's kind of the granularity of those two different kinds of feedback.
Okay, thanks, David. Some more questions are rolling in. There's a question here around how do we use the summarize feature internally here at Sumologic?
Okay, so one thing is that it's really nice to get this sort of, when you don't, it's kind of the unknown unknowns, when you don't really know what you're looking for, but you know that something is interesting is happening on a particular system, or you don't know anything about that system and you're just trying to sort of get a feel for what kind of log messages are emitted by it. So you might be, any given modern system has a pretty sizable code base with a lot of different components, and not everybody is going to be an expert on all of them. And so if you're troubleshooting something on a component of our service that a given engineer is not that familiar with, they can summarize the logs coming from that component and sort of get a very quick digest of what kind of activity happens on that component, what's going on. So really just this sort of at a glance, very quick understanding of something when you don't know exactly what you're looking for. So very exploratory. I'd say we get a lot of mileage out of it using it in exploratory contexts internally, where you just want to poke around the logs and see what's going on, and really, as opposed to just, again, thumbing through tens and thousands, tens of thousands of pages or of logs and many, many pages. If you want to explore a given set of data, summarize is a great starting point for kicking off an exploration of some data set or some behavior. So that's really one of the strengths of the tool that we found internally.
Okay, here's another question. Are the log patterns of signatures filtered at index time?
Okay, so right now that is not something we do. That's an interesting question, absolutely. Right now that all happens, all of this processing happens downstream of the indexing pipeline essentially. So it's not something that gets used in that way at this time.
Okay, another one here is around bug hunting. For bug hunting, once you have the log summaries, can you automatically grep back into the code and show the user developer where the printout is coming from?
Okay, so that's a really interesting question. We don't, so I'm not 100% sure on the context exactly. Certainly the sumologic service does not have, at this time, access to your source code. But really what we actually internally, so when we like I said, we dog food it very heavily, it doesn't even have access to our source code. So when we're using it internally to troubleshoot some kind of issue or investigate some abnormal behavior, what we'll do is we'll just grab a particular string, we'll just take the signature itself and grab some sequence, some subsequence of the signature, and then just actually, git grep that through our own code base to using that as a sort of start off point. And you can pretty easily identify the statement or statements that generated that signature. So this is a situation where you can kind of copy and paste out of the browser and into your terminal to achieve that kind of effect.
Okay. Another question here is, how quickly do we learn or detect new signatures?
So right now, new signatures are detected every time you run a summarized query. So this basically happens as you run the query. The logs that are running through the system get evaluated and we see if they're really, what signature do they belong to, or do we need to infer a new signature. So at result time, whenever we'll be able to learn new signatures on the fly, essentially, which is important for us too internally, because in the of course in the software world, nothing is really static and unchanging. We're always adding new logging statements to our own code, and so Summarize and LogReduce evolve as the data evolves, and they'll learn new signatures to explain new data.
Okay, here's another one. Is there any way to slice and dice logs matching a specific pattern or signature? And if not, are we planning to support that feature? Right.
So right now, you can sort of fake that behavior a little bit by doing some query language gymnastics. What you could do is that the output of Summarize, you could sort of try to pipe that through something else. The functionality at the very end that I showed with the charting is actually we're planning to expose LogReduce through a new kind of interface that's more suitable both for charting and for that kind of slicing and dicing that you just asked about. So that's something that's not perfectly supported right now, but certainly on the very, very short-term roadmap is a way that you can manipulate LogReduce results sort of as first-class citizens within the sumologic query language.
So one more question here is, can I create a daily scheduled search summarizing error logs of the previous day?
Right, absolutely. So Summarize can be used within the sumologic scheduled search and scheduled search alerting functionality. So you can take a Summarize query and turn it into a scheduled search. That might be really useful. Again, people find it pretty handy to say, okay, particular system component and error exception failure or something, and pipe that through Summarize, and then you can kind of get a morning report that says what error signatures did we see over the previous day or the previous night or something like that. So certainly you can integrate LogReduce into your sumologic scheduled search and scheduled alerting capabilities.
Okay, thank you, David. Well, that's all the time we have for today. Wanted to thank everyone for attending the webinar. Again, we will be sending a recording of the archive to all of the attendees. So thank you again for attending, and please enjoy the rest of your day or the rest of your evening.